Okay, page 11 says properties of rectangles. So this is going to be lesson 6.3. Properties of rectangles. So 6.3, you can just write rectangles. It says rectangles have the same properties as parallelograms. So we have opposite sides congruent, opposite angles congruent, diagonals bisect each other. But then we have two more things that have to do with rectangles that aren't necessarily parallelograms. The first one is that all four angles in a rectangle are right angles. So all four angles are right angles. And if they're right angles, what does that mean? They're 90 degrees, and they are all the same, right? So let's draw a little picture over here of a rectangle. And in the corner of each of these, I'm going to put my 90-degree box, because I know that all four corners are 90 degrees. Now, Monica, I could split this, right? I could split this angle up to be something, but together they have to be 90. Brian, they're not going to be split in half exactly. It's not going to be 45 and 45. It could be 60 and 30. All right, so we have to be careful of that. Okay, the second thing that a rectangle has that a parallelogram does not is that the diagonals are exactly the same. The diagonals are congruent. They are the same length, and that was not true in a parallelogram, right? One was shorter than the other. But in a rectangle, the diagonals are congruent. And if you draw an example, they look like they're stretching the same amount of space, right? They look to be the same size because they are. Okay, same rule here. We're going to do just the odds on these problems. So let's look at number 1. See what you already know about number 1 as I move my screen. Sorry, I wasn't trying to snub you. All right, if PQ is 24, what else do we know? SR is also 24. Okay. Braxton, if PS is 10, how much is QR? 10. All right, so we have satisfied the first two. But how are we supposed to get inside this rectangle? Okay, we're on the right track. We know this is 90. I wish we had learned something about a 90-degree triangle when you know two sides. Thank you. A squared plus B squared equals C squared is going to give us P to R. Now, PR is going to be the hypotenuse, right? Because it's across from the right angle, so that's the C value. So we have to be really careful when we plug it in. 10 squared plus 24 squared equals C squared. So I have a right triangle there. My PR is my hypotenuse, the one I don't know. Mm-hmm.
Alright, so they're all, you know, the right angles. How do we know inside?
So the hypotenuse?
Yes.
Okay. So if I did it this way, what if I did this one up here? This is a right angle, right? This is still my hypotenuse, isn't it?
Oh, yeah.
So no matter which triangle you draw, your hypotenuse is still going to be the diagonal. Even if you went this way, Your hypotenuse is still the diagonal, and the diagonals are the same, right? So if you find one, you found the other one. Okay? All right, what are you getting for your complete diagonal? How much is the complete diagonal? 26. So the third thing they're asking me for is SQ. So I know that SQ is 26. And so if SQ is 26, that whole big thing is 26, then each of these four pieces inside are how much? Brian says 13. Anyone agree with that? This is 13, this is 13, this little guy is 13, and this one is 13. They're all 13. PR is 13, and then QT is also 13. Okay? Any questions about that one? It's the same thing. I'm sorry, PR is 26. I wasn't paying attention. I'm sorry. PR is 26. What's 26 divided by 2, Monica?
13.
So each of those pieces is 13.
Why do I do that?
The diagonals bisect each other, which means they cut each other in half. Okay. All right, let's try number 3. Number 3 is now going to deal with the angles inside. Okay. So one piece of it is 27. Does that mean, Brian, that the other side of it is also 27? No, I mean like the underneath it is also 27? Like angle MJL, is that also 27? No, because they're not equal, but they do what? They make 90, okay? So, Brian, you said if this one is 27, what else is 27? MLN is 27, okay? Not L. L is the two angles together. Okay, so if that 27 and whatever else has to make 90, or Tincy, what is 90 minus 27? $63. So this is 63, and then this one up here is 63. Okay, I'd like you to pause for just a minute and look up at my diagram. If I know that these pieces in a rectangle, okay, are congruent to each other, then this triangle that I have just created is what kind of triangle? If these are congruent to each other, what's that called? What's a triangle called when it has two congruent sides? Isosceles, right? This is an isosceles triangle, and if the sides are the same, what do we know about the angles across from the sides? They're the same. So if this bottom one is 27, then how much is this guy over here? 27 as well. Okay. Now let's move to the other triangle then. If I say that this one on the side here that I'm putting in black, these diagonals are also the same, right? So what do we know about those two angles? If the top one is 63, the bottom one then is also 63, right? And then this continues, this trend continues. So this is 63, and then this one up here is 27. Now the question is, how do I get the angles in the middle? Any idea how you get the angles in the middle, Monica?
You subtract by each triangle, you subtract 180.
Okay, so Monica's reminding us that we have a triangle. Let's use the 63 and 63. So if I add up 63 and 63, and I take that away from 180, it's going to give me this middle one right here. How much did you say it was? 54. And then, don't we have vertical angles, guys? 54, and this one over here is also 54, right? Okay, let's find out how much angle N is. So 27 and 27 added together. Subtract that from 180. So if this is 126, then the one above it is also 126. Okay, last thing I want to point out about this. Look up at my diagram. What do you notice about these two angles together?
They should be equal 180.
They should equal 180. Someone check. What is 126 plus 54? 180? Excellent. All right. So if both of those are 180, then the other side's also going to be 180. let's try number 5. Okay, let's try number 5. I'm going to give you a minute to set it up. Okay, dB is 42. So if dB is 42, how much are each of those little pieces? 21? Ooh, yellow is hard to see. Sure. Is it really bothering you?
I was gonna go outside.
You're welcome to. Okay. 21 and 21. AD is 26. And, okay. So here's what we know. Over here is also 26. To find that missing bottom piece, aren't we going to have to do a squared, b squared, c squared? Again. But this time, we know the hypotenuse, right? We know the hypotenuse is 42. Oh, yeah, 42. Right, because we can add those back together. So we could say 26 squared plus x squared, and x is representing down here, equals 42 squared. Okay, so let's figure out what that missing side is. Again, we have our hypotenuse here is 42. That's our hypotenuse, so that's going to go in for our c value. A squared plus b squared. Yeah. Can you wait like 10 minutes? Can you hold it? If you can't, you can go, but...
Yes.
Okay, so what are you guys getting for that missing side? Anybody have it? 33? What'd you get?
32.9.
32.9.
Well, it's 32.98, so I rounded it.
32.98. Okay, so yeah, let's round to 33. So we'll say that this side is 33. If DC is 33, what else is 33? AB is 33. So if we fill in our sides, I'm going to fill in my sides so that then I can erase my sides, okay? So AC is 26. Now let me encourage you, hear me clearly. If you erase, you need to have work shown somewhere so that you don't just magically have the answers. Okay? EB is 21. BC 26, and AB 33. Okay, are we okay so far with those 4? Let's talk about our angles. So I'm going to erase what's up here.
Oh, yeah.
Okay. It would be beneficial to you to redraw it instead of just erasing it. Okay. All right, it says angle DAE is 52. So now this is like what we have been doing. Okay, if that one is 52, then isn't this one down here also 52 because of alternate interior angles? Okay. And then we learned, right, that this is an isosceles triangle. So if this one's 52, then this one up here is 52, right? Same thing over here. This one's 52. Are we remembering that okay? And then the corners add up to be how much total?
90.
90. So how much did you get for the corner that goes with 52, Brian?
38.
Are you guessing or are you... The angle corner that goes with 52, you have 38 on your paper. Okay, so 38, which means this guy over here is 38. Then we have 38, 38. You okay with that so far?
Yes.
Now, how do we get the ones in the middle? What do we do again?
Subtract.
Add the two angles already in the triangle and then subtract from 180. So if we subtract from 180, we are getting all three angles in this triangle make 180. So if I add 52 plus 52, that's 104. 180 gives you, what did you say, Brian?
104 and 76.
104. So 104 goes into, oh, that's how much 52 and 52 is. So that means this is 76.
Yep.
And this is 76. Okay. Yep, exactly. And then you know another way to figure out that other missing angle is to say that these two together make 180. You could do it that way, right? So that would be 104. 104. Woo! 4 more days. I'll go into these in there.
I don't really want to leave.
Okay, any questions on number 5? No. We okay with that? Are you guys okay labeling your correctly, finding the correct measures to go in the blanks?
Yeah, no, these are easy. The ones before I for whatever reason. Can you like those? And then like I feel like they sound like really the same. Like,
Okay, let's go on to number 7. Okay, number 7, it says if RT is 5x minus 14, so we're going to label RT is 5x minus 14. So RT is 5x minus 14. And US is 2x plus 2. What do we know about diagonals in a rectangle? They're the same, right? So I can set these two equal to each other. Okay? Let's go ahead and set them equal to each other.
oh,
It's the second time I've heard that today. Must be true. Okay, so we're getting x to be 8. Okay, so if it's asking us for VT, that's only half of the diagonal, right? So if I figure out how much the whole diagonal is, I can figure out how much it is. What? So when we find US or RT, how much are you getting for the full thing? 26 is the whole thing. So like UT, the whole UT is 26. I'm sorry, US. Let me write that. US is 26. So how much is just UT or just VT? Oh my gosh. It's because my brain is done. What'd you say? VT is?
13.
13.
Can you
Good.
put a line over VT?
No, because we're talking about measurement, and measurement does not have a line over it. Okay? Why don't you try number 9? That's what Sharmany got.
Yes.
So VW is 9x minus 11, and SU is 16x minus 12. So did we double 9x minus 11?
Yes.
2 times 9x minus 11 equals 16x minus 12. Is that what you guys did?
No.
Yeah.
Okay, so we're going to double it, right? Because 9x minus 11 and 9x minus 11. What are you getting for x?
5.
X is 5. Yes?
Yes.
Yeah? Okay, so if x is 5, it says plug back in to find WT. Well, isn't VW the same as WT?
Yeah.
Okay, so if I plug x into VW, that's 45 minus 11, 34. So WT is 34. Okay, let's look at number 11. Shh. Let's look at number 11. We're almost done, guys. Okay, find measure of angle JHI. Well, before I can find JHI, I need to use what they had given me. Okay? So they gave me measurements for the two angles in the corner, and the two angles in the corner have to do what? Equal 90 degrees, right? So I know that these two added together have to equal 90. So that's where we're going to start.
Yes.
3x plus 2 plus 12x minus 17 equals 90 degrees. Okay, so 15x minus 15 equals 90. All right, so we're finding x to be 7. If I'm looking for angle JHI, let's make an arc by JHI. Angle JHI is up here, and I need it to be the same as which one? The 3x plus 2, which is the GJH, right? This one and this one, GJH. So I'm not going to plug it back into 12x minus 17. I'm going to plug it back into the 3x plus 2. You guys okay with that? So 3x plus 2, 3 times 7 plus 2, 21 plus 2 is 23. So to answer the question, measure of angle JHI is 23 degrees.
I accidentally put in x for 12x minus 17, so then I took it 90 minus that.
I would give you the answer.
So we get x equals 7, then we plug it back into the opposite because we're finding G and E. Or I'm sorry, J and H.
Well,
And
we're
this
finding
is-
an angle, JHI. J to H to I is this angle down here. Right here, this
in the
one.
middle.
And this is the same as this one because they're opposite interior.
Okay.
So that's why I plugged it into this one.
Got it.
Okay, last one. Let's do number 13. I'll let you get started and see what you can do on 13.
This is just put in
Two angles together don't make 180. Try that again. You actually have to do some work. No, don't ask him. Do it on your own. Think about what we've been doing. I didn't ask if you wanted to. I told you that you need to. Okay, think about what we've talked about in a rectangle, about the angles in a rectangle. Okay, but in a triangle, right? Because we have this triangle, which is what we're going to have to deal with here. If this outside angle is 134, Brian, how much is this red angle that I'm marking?
46,
How do you know that it's 46?
because I took 134 minus 180. And get you
So this is 46. Okay. Then what do we know about the two blue angles? That they're equal, right? So if the bottom one is 5x plus 7, then this one is also 5x plus 7. And then we know that all three angles in that triangle add up to be how much? 180. So I can do 2 times 5x plus 7
plus 46.
plus 46 equals 180.
I can get all that back.
You guys okay? Questions? Does that make sense?
Yeah.
Did you figure out? Okay. No. Okay, solve it out. Why are you stopped? Keep working.
See. Miss Mary, please
You have 215x. You have 215x.
No, it's my.
Oh, your parenthesis? Yes.
I was just gonna tell you, please don't judge all of us.
2 times 7.
Oh, yeah.
2 times 7 is 14, not 17.
Oh.
Hey, Brian. I'm the only one that did that. I just made my 7 look like a 4.
What'd you get? Good.
Miss Miriam.
Yes. Yes, good. Anyone over here have the answer?
No, I got
Good,
12.
Hortensia? 12. What'd you get? 12? Why'd you
I
stop?
did it wrong because I didn't add these two together.
Well, and this is 5x plus 17, and this one up here is also 5x plus 17.
Plus 17.
Oh, 7, I'm sorry.
Okay.
These two
Oh,
together,
yeah,
right,
yeah,
are the
yeah.
same. Okay, we're getting x to be 12. Prove to me that x is 12, please. All right. So for your homework, you need to do the evens on the last lesson and this lesson. Okay? So we skipped all the even problems, but there's an odd problem exactly like each even problem. Okay? Nope, not the page that we skipped from the parallelogram. So page 7. Page 7, you need to do the evens. And then page 11, you need to do the evens. They, in fact, are marked homework 29 and 30. Or 28 and 30? 28 and 30.
28, 30.
Yep.
No.
For right now, we are skipping page 9. Yes. We are skipping page 9.